Hello, everybody. My presentation today, I'm going to cover a little bit briefly about the history of Wi-Fi design, and then I want to have a kind of a look forward and what it could potentially be as new Wi-Fi technologies emerge. So I'm Dave Coleman. I'm with the Office of the CTO of Extreme Networks. If you're not linked up with me, please do. I'm one of those old guys in the woods that Alexis was talking about. That was an excellent presentation, by the way. Since I'm dating myself, we learned that Queen performed on this stage. Well, I saw Queen 50 years ago in 1976 in Atlanta, Georgia, when I was 16 years old. So I have a lot of memories by that, so it's kind of cool to be standing on the same stage. Now, quick shout out to Ekahau, who has been on the cusp of the evolution of Wi-Fi design since really almost like the year 2000 when the company was formed. Some of you may not know but that Ekahau actually started as an RTLS company, and then in the mid-2000s they pivoted more to Wi-Fi surveys, design, and troubleshooting. And then over the years, Ekahau Site Survey kind of became the de facto standard for Wi-Fi design and modeling and survey. It really became kind of the golden standard. And then, of course, in 2017, they introduced this little engineering marvel known as the Sidekick. In 2022, you got the Sidekick 2, and then Ookla bought Ekahau, I believe, in 2018 or 19, and then in the last couple of years, we've been watched Ekahau move more towards the cloud and also use AI as part of their design strategy. So kudos to Ekahau. Now, just briefly at a high level, how things have changed over the last 26 years is in the early days of design, it was all about coverage. There weren't even any modeling tools available. It was AP on a stick. You went around, you took measurements. The concept of capacity and client capabilities, nobody even thought about that. All they cared about was coverage. And that's pretty much how designs were done in the very, very early days. But then we started getting better tools, and then priorities changed too. It wasn't just about coverage. Now you had to, starting at, I would say, really in around 8 to 11 in days, around 2009, 2010, when the enterprise embraced Wi-Fi and it became more ubiquitous, you had to start thinking about capacity, and you had to start designing for capacity needs. How many users? Where are the users? What kind of devices do they have? Are they 1 by 1? Are they 2 by 2? Yes, there was even 3 by 3 laptops. And what applications are they using? And then the next step from that is absolutely related to capacity design was designing for airtime utilization. And I know that's a strategy that a lot of people have successfully used for a long time because you have to think about that precious commodity of airtime. You need to cut down on your co-channel interference. Channel reuse patterns became even more important. You had to trim the lower data rates. You had to consolidate your SSIDs and numerous other things that you could do to tweak or design your network and tweak your operational network so that you could have the best use of your airtime. Now, this is my friend Carl Benedict, and you've probably seen him on stage before at other events. He works for us at Extreme Networks, and his design and troubleshooting skills are top-notch. And he has been preaching for many years about designing based on RF characteristics. And what I mean by that is he is very, very concerned about the attenuation properties and other properties of the walls and any kind of characteristics within every building. And think about it, every building is different. Okay? Now, when a lot of people do a design, a common strategy is maybe you go on site, you do a few spot checks for attenuation spot checks, then you do a predictive model, then you deploy, and then you validate. Pretty good strategy. But Carl's contention is that the attenuation spot checks are not enough. Because if you think about it, a drywall that might go across a wall 25 feet, and maybe it attenuates 3 dB in one section, but believe it or not, you walk 10 feet and it might be attenuating 6 dB because you don't know what's inside that wall at different points. So being able to figure out the RF characteristics before you even do your predictive model is actually gold. And as Carl says, if you can get the RF characteristics down, then the RF design will come just naturally. And that actually goes into the discussion about how AI has found its way into today's modern tools, including Ekahau. So just a perfect example is you can use the Sidekick now, and you can go walking around and gather RF information based from an existing network or some APs that you slap up, and then you can use AI and ML capabilities to help you determine the actual real attenuation of the walls and RF characteristics in the building. And that is light years ahead of getting an image and just drawing lines on it. Okay? Other things where AI has enhanced modeling and design. Clearly, propagation models have been enhanced by machine learning and AI algorithms. AI capacity planning has been enhanced as well. And even if you're inclined to do auto placement of APs, that has gotten better with the newer technologies that are driven by ML and AI. And so hopefully Ekahau will continue down that journey. Now, I don't know if anybody saw me do a presentation in Phoenix, the video of it, at WLPC. I did this presentation where Carl and I took a bunch of spectrum analyzer data and we fed it into ChatGPT, and we wanted to see what insights we could derive. And surprisingly, it was pretty interesting. So we decided to take it another step, and we decided, well, what if we could feed a project file from Ekahau that was captured from a Sidekick 2 and feed it into ChatGPT and see if we could draw any additional insights. So think of this as just like a little fun exercise that you might want to repeat one day on one weekend when you have, because I know we have a lot of geeks here that like to do things like this, not just me. So if you open up an ESX file, it consists of mainly a lot of JSON files, which is just a structured data format on how computers store and share information. And also there's binary files. One that is the Sidekick uses to track data on how it moves and positions during the survey, and also the raw RF spectrum data. So we went to ChatGPT and we said, hey, can you analyze the data from an ESX file that we captured with our Ekahau Sidekick 2? And it said, absolutely I can. And it said, we can look at these things inside of it, and then it prompted us to start being conversational. Now, my buddy Carl spent like 2 days playing with this. I didn't have as much patience, and we had mixed results, honestly. He got some pretty good insights if he trained the data a lot, and was very, very conversational, and fed it other data, including screen captures that he took from the Ekahau AI Cloud, okay, of the spectrum analysis and even of the coverage and the co-channel interference. And if you can correlate some of that data along with what they sees inside the file, it actually got better. Was it great? Not really, but it was okay. We did ask it to make recommendations on how we can make things better, and it surprisingly was very, very good. Not always accurate. Sometimes it would say stupid things, but it surprisingly got you thinking. And so that was kind of the fun part of the exercise. Now, if you were to do this exercise on your own, my suggestion would be conversational, okay? Anytime you work with generative AI, the more conversational you are, the better it will be. I found it did better if you just unzip the JSONs using like zip from the EXS file in the bin files, before you uploaded the entire EXS file. So if you just uploaded the JSONs independently and the binaries independently, it did a better analysis. It tended to ignore some of them if it was just all zipped together. And that also goes because there's also a maximum file size too, so that assisted as well. The other thing I said, also use supporting files as well if you want to go through this exercise, and provide supporting information, like the last presentation talking about all the client capabilities. Providing that, and also provide your requirements for the design you're doing. Now look, this is just a fun exercise. The good news is you don't need to really do this because Ekahau has spent numerous financial resources and numerous engineering resources on machine learning and AI already. So that being said, this was a fun exercise. And I will say there was one last thing that I did find very valuable with this, and that was to use ChatGPT to assist you in defining your requirements. So I just did an imaginary design, and I asked it to define requirements for me for a 50-bed hospital, and it was really good. Now, chances are you or your customers already have defined requirements. You could feed that into the generative AI, and I promise you, it will enhance those already defined requirements and get you thinking to maybe even make you define your requirements even better before you do your design. So that's food for thought. So let's talk about the future. Wi-Fi 7 is already here, but it's not really mature yet. And the one feature that I do have hopes for, it's not mature yet, and that is the EMLSR link steering. And so that's all about enhancing latency by moving back and forth between 5 and 6 gigahertz. Still very early days on how well it's going to work, but that being said, let's just say it starts working. What if we could build into design tools some sort of client profiler specifically to define, let's say, latency SLAs based on EMLSR behavior? So it's, in other words, saying, hey, I have 50 Wi-Fi 7 clients that support this. Can you tweak my design and help me with my latency SLAs? Another thing that is going to be huge, I think, moving forward is anytime we get an RFP, especially here in Europe, sustainability is part of the list right here. So as enterprise vendors like Extreme, we're trying to build dynamic capabilities where some of the radio chains power down when there are not people in the room to save energy and provide eco-insights. Well, so what if Ekahau or other design tools had like a slider bar that you could move to for sustainability goals? Now, I'm not saying to ignore coverage and capacity goals, but you might be able to tweak your network simply to provide visibility for things like how much energy you might be saving, how much CO2 is being saved on a monthly or weekly basis, and even euros or British pounds.
Nico's taking a picture of it now, so it's going to happen.
Okay, all right. Awesome. I can expect that next week, right?
Tomorrow.
Okay. So there's another technology that holds interest to me that really hasn't found its way in the enterprise yet. It's more of a consumer-grade technology, and that's 802.11bf with channel state information, where people move and then it affects the RF waves, and then you can get insights from that. So how it's being used on the consumer side right now is if Grandpa Coleman falls down the stairs right here, it sends a message to the smartphone, and you got to go pick them up. Now, but there's other use cases, including occupancy analytics. The technology is getting better, and I think it's going to find its way into the enterprise. So, it's very early days, but we might want to provide some sort of simulation capabilities in our modeling tools for this technology when it does find its way. Locationing will continue to be important. Look, it's been around forever. But most vendors now have a tiered strategy for locationing. BLE asset tags are pretty mature, especially in healthcare. Vendors are starting to put UWB radios in their access points. And also 802.11MC and AZ for next generation positioning. That technology is getting better, and more use cases are starting to pop up. So you're going to see vendors maybe use this three-layered strategy and sometimes maybe even combine the technologies. And clearly, we're going to need the modeling tools and the design tools to continue to support that. Wi-Fi 8. I can't believe I'm talking about Wi-Fi 8, but you know what? It's coming in early as late 2028, probably more in 29. And the main thing it's going to define is multi-AP coordination. So imagine a Wi-Fi 8 AP connected to two APs at the same time. Now, the most interesting prospect for that is that could really define zero latency times, which I think latency is going to be the most important metric moving forward in the next 5 to 10 years. And it would greatly enhance roaming because effectively there isn't a roam. You're connected to two APs at the same time. So think what that could mean for a design tool. This is vaporware, but if this actually ends up working, think what that can mean. We may have to do designs of AP clusters, like roaming clusters, where you have two APs where you know Wi-Fi 8 client's going to connect to, and then it has to have a secondary coverage with another cluster of APs. So food for thought. Well, I'm always a skeptic. Just prove it to me first. But they're already working on the silicon, and it's coming. And speaking of next generation APs, this has me very excited because I think in high-end models, in about the next 4 years and beyond, we're going to start putting AI GPUs inside AI chips right there in the edge of the network. And what that means for vendors in terms of the processing power and the whole concept of edge compute, because cloud compute costs are very expensive. The possibilities are endless with the analytics and with things that we're going to be able to do with it. So here's my challenge to these two gentlemen. How many people in the room here, show of hands, own a Sidekick 1 or 2? Everybody. Well, this is what we need for the Sidekick 3. We need an AI chip. We need an AI chip. Where you can do real-time processing and analytics with your spectrum analyzer information and your packet captures and AI-assisted surveying capabilities. So they'll have that by next year too. Now, I may have to, Matt, run like 1 minute late if that's okay. This is something I've been saying for a long time, and something that every enterprise vendor, including my company and my competitors that are here in the room, have been getting wrong forever. And that is we've been looking from Wi-Fi from the wrong side of the signal, okay? Everything we do in terms of monitoring and troubleshooting is from the perspective of the radio in the access point hanging in the ceiling. Now, that's completely wrong. We should be visualizing and troubleshooting and monitoring from the perspective of the client device. I can promise you that your end users don't care about the experience of the AP. They only want their Wi-Fi connection to be fast, frictionless, and secure. So we're already seeing this in tools like Ekahau, where we're starting to visualize the user experience and in modeling tools. So I would rather see the coverage from the client's perspective. I would rather see, in both real time and for modeling, what the next top roaming neighbors might be for a client, because that's going to give me a much better view from a client perspective. Now, that being said, to achieve this properly, you need data from the clients. So last year, we announced, Extreme announced a partnership with Intel, and so I'm just going to do a quick little demo here of some agentic AI solution that we've put together that takes data from Intel clients along with data from our APs, our infrastructure, and correlates that together into an AI core, a data lake. So if I can get this to run, I go into the system and I ask it a question, if it is running. Which locations of my network have the most roaming failures? Okay? And then it will do calculations. It will process the data that's coming directly from the Intel clients, as well as the location awareness data that's coming from our APs. And then it correlates that in a graph, and you can see we have 60 roaming failures in New York. That's a crappy network. Now, the next question I'll ask is, can you tell me what the cause of the roaming problems were? And then, based on getting the data from the clients, as well as reason codes from the APs, I'm going to get a much better perspective of why I'm having these roaming failures. So this is a new AI platform that we're building. This is actually a proof of concept, but it's being built into our AI core that I'm going to talk about in just a second. Thank you, sir. Okay, and I'm almost done. So, once again, my point is this. We need to be thinking more about the client perspective, not just in our real-time networks, but also from when we're designing our networks. And, I heard Matt talking about optimization earlier, and, you have it's the whole concept of the digital twin, right? You're taking telemetry data from your real network into your simulated network, into your design tools, and you basically have a feedback loop. Well, I see nothing wrong with also throwing client telemetry data into that feedback loop, and I hope that's where we're headed as an industry. So I have two more slides to wrap this up. One shameless plug here is Extreme announced our next generation cloud management platform called Extreme Platform 1 that's going GA in July, and it's being built on an AI core that uses agentic AI. And the year of 2025 is the year of agentic AI. You've probably heard a lot about it. It's a concept where you have human collaboration with an army of AI agents. And these AI agents have different tasks. And they have access to different tools like LLMs, small LMs, APIs, live telemetry data, and then they can work in collaboration with each other to help you get a better view and solve problems on your network. So I see no reason that in the future we might also see agentic AI systems for Wi-Fi design, where you have some sort of collaboration agent that works as kind of the boss of all the worker agents that have different tasks, like AP selector agents, coverage agents, capacity agents. Heck, you might even have a Wi-Fi ninja agent. So with that, thank you for having me here. I just want to leave you with this thought. This is something I've been talking about a year. When you look at all the ingress data that goes into access points in the enterprise, 75 to 80% and higher in some verticals, it starts with a Wi-Fi access point, okay? So when you start talking about big data, when you start talking about analytics, when you start talking about insights, and including business insights, it starts right there on the edge of the network, and it's transported via Wi-Fi. Thank you very much.